Hello friends and colleagues, welcome back to ClojureRank. We're solving Hackerrank problems in Clojure until we run out of problems, I guess. And yeah, check out this one I found. We are building toys out of three-dimensional cubes. There's a cute backstory about Madison and Mason who are building the cubes. They're never mentioned again. And this is, as you can see, this is the shape of it. So we want to get the surface area, and so it's it's basically a counting problem. We have to count the faces of these individual cubes, because it's all discrete. It's not like a 3D multiplication problem. We can't just multiply length with height because, well, we can't here. The surface area of this is 6, of course, but the surface area of this irregular solid is what do they say it is? They say it's 60, and that's because, like, let's see, so on the bottom we have 9, on the top we have 9. Is that what they say? I'm seeing, the entire bottom and the entire top facing up are populated, and so that's 18. And then these brightest ones, these rightward facing cubes, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those. So that's 18 plus, well, okay, I have Clojure, so oh, are these necessarily left and right, top, bottom? Yeah, okay, so left, right, top, bottom, front, back are always, I think, going to have the same amount. So let's start over on this. Nine, because 3 times 3, the top and bottom are fully filled in. Oh, but there's also right. So it's not just faces. Is it? Never. That's not a good approach, because I'm looking now, and like this guy here and this guy here are doubled up as far as right hand faces. Right, and so I saw this. I sub j is always greater than or equal to 1. So there's no, and these are, I and j are the floor axes, width and length, and then the up axis, the y axis. Y is usually up. So I guess x and z would be I and j. They're calling them. And basically it's saying that what this tells us is there's no squares that don't have a cube on them. So we know that width and height are what we're given, height and width, and so we know that that surface area is going to completely be filled in. So like in this case, 9 on the bottom and 9 on the top. We have that much surface area to start with, and then we have to compute the horizontal facing surface area. So let's get started. A here's a two-dimensional array. So I'm iterating over each of the columns, looking at I and J. We're treating each of these as like a column, and for each of the columns, looking at the top, there's going to be so many units of surface area. So like this first column, which would be 0, 1, 4, column 1, but 0 really. So like this column here, it's got 2 units of horizontal surface area, of wall area, so to speak. It's got 2 units of wall area because, so a cube, right? A cube has 6 units of surface area. And this particular cube, this column has only 1 cube in it. And the back surface is exposed, and this right hand side surface is exposed, but in front of it is on the inside, it's not surface, and to the left of it, it's on the inside, it's not surface. So it's got 2 units of surface area. And then this next column gives us 1, 2, 3, 4 units of surface area. And so on. And we just do this for each column, and we find out that all these wall areas are going to add up, and then we add those to the ceiling area and the floor area, and we get the total surface area. And we know that if I or J are 0, or if they are the maximum, then the height, I don't like calling those width and height. They called these width and height, and this is something else. Ascent. Let's call that ascent. Then the A, the total A is going to be surface area. So like where here, let's call this one I and this one J. This column here is going to have a total, the A here is 4. And so on both the I-axis and the J-axis, because it's at the end of both of those, it's going to have 4 units of surface area represented, in addition to the other sides. Before is just if it's 0. And now if I is not 0, so this is, we'll call this the I-axis, and when I is not 0, the contributed surface area is going to be the height A minus the height of the previous column. And in the case that the previous column is higher, it's going to be 0. So this is just the before. So it's not 0, so we can subtract 1 from it. And then we can say that max of 0 or subtract from A after is the same thing, but instead of checking for I0 and subtracting, we check for IW minus 1 and we add. So for at the end, we use the whole height as height. We use the whole A as surface area. And if we're not at the end, then we subtract from the subsequent. We subtract the subsequent column. And then we do the same thing, but manipulating J to check to the right and the left. And I'm just arbitrarily going to say that right is positive and left is negative. no. Get A, so we keep I fixed, and we manipulate J. Hold on, so if J is at the end, then the whole thing, otherwise possible to increment J. No, I forgot about ink and deck. I shouldn't be doing these ugly minuses and pluses. These gets aren't going to work. It's get in, isn't it? Not 0, so we can deck it. What's wrong here? It's returning nil. Oh, because I did all this let and then I forgot to, right. We don't even need to flatten, we can just add. Line 29, what's going on there? Lazy seek cannot. Okay, so I know top bottom area is a number. And well, here. This is what I do in these cases. Oh, okay. Where are we trying to add vectors? There, okay. Now this one should have 2, 4, 7, 10, 11, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Weird. What did I miss? Did I miss something? Somewhere I missed something. It's all me. 4, 7, 8, 9, 10, 11, 12, 13, 14. Okay. Let's try the other example we're good. 3 by 3 has surface area of 60. Clojure is such a gift. So it's the little things. It's the little things that make it so ergonomic to work in. Cool. That was fun. It's all right. Thanks for watching. Let me know if you enjoyed the video. If you have any questions, I'll be happy to answer them. Don't forget to click like and subscribe so you find out when I make new ones. I'm going to be making videos like this on a regular basis.